Welcome to my latest video on limiting reactant or reagent stoichiometry. Now this is a difficult concept in chemistry, and it's probably, at first it'll seem like one of the more difficult things we cover this year, but it's actually not too bad, and I have two practice problems that I'm going to be going over in this video. And I would encourage you to, if you're feeling confident now, go ahead, pause the video, try to solve this one. If not, watch me do the first problem, and then you'll have an opportunity to try to solve the next one on your own. So limiting reactant stoichiometry at its base is really talking about how much product we know that chemical reactions have products that they produce from reactants. So it's saying how much product can I produce if I have a mix of maybe different amounts of reactants. And the way that you can think about this is maybe making pizza. So if we just maybe scroll over here for a second. If you want to make pizza, well, if we really dumb this thing down and we simplify it to its simplest components, a pizza, we can say over here, is a collection of, well, we have dough and then sauce. It's kind of a plain pizza. It probably wouldn't be very good, but we have this pizza over here, dough and sauce. So to make this pizza, well, what do we have to do? Well, I have to add some dough. So I need, one pizza crust. And I'm going to add that to some sauce. All right, so maybe, one dough, and maybe I need 2 jars of sauce over here. So 1 pizza dough plus 2 jars of sauce gives me this pizza. Well, what limiting reactant stoichiometry is really getting after is it's saying, okay, well, what if you have 1,000 pizza crusts and 50 jars of sauce? How many pizzas can you make? Which one's going to run out first? Which one is your limiting reactant? And that's all we're really doing here, but of course we're not doing it in a simple way, but we're doing it with a chemical reaction. So let's go ahead and begin. Let's try this one. Let's see here. So it says we have this chemical reaction. 4KO2 plus 2H2O yields 4KOH plus 3O2. And it says if a reaction vessel contains 0.15 moles of KO2 and 0.1 moles of H2O, which is the limiting reactant. So what we want to do here is we want to write down all of our information first. So it says, okay, 0.15 moles of KO2, so I'm going to write that right underneath. So 0.15 moles. Okay, and then I also have 0.1 moles of H2O. Okay, so 0.1 moles of H2O. So what I want to do is I'm going to do this one at a time. And if you can kind of envision me on the other side of the computer, what I really do is I take my hand and I cover up one of these reactants, so either this KO2 or this H2O, and then I assume that I have an infinite amount of that product, and then I see how much the other reactant will give me. So for now, let's just completely ignore KO2. We'll just imagine a hand covering KO2, and we're only given this 0.1 mole of H2O. So let's figure out how much O2, how many moles of O2 I can actually produce with that 0.1 mole of H2O. So and then what we'll do after is we'll ignore H2O. We'll figure out how many moles of O2 I can produce using this 0.15 moles of KO2. And then whichever one will really give me the least amount will be my limiting reactant, because of course I'll run out before I can make any more. So let's go ahead and try this one out. We're going to use dimensional analysis, and we start with 0.1 moles of H2O, and we are trying to get and convert our units to moles of O2. So that's what my end goal is on the right. So let's go ahead and run through some dimensional analysis. So 0.1 mole H2O. Since I'm already in moles, I can jump right to the mole-to-mole ratio. So if I look at my chemical reaction, it takes 2 moles of H2O to produce 3 moles of O2. So that's my mole-to-mole ratio here. These molar coefficients in front tell me that. So I can use that. I can say, okay, well, moles H2O on the top. So 2 moles of H2O will give me 3 moles of O2. And that's just using our mole-to-mole conversion factor, just like any other conversion factor, 12 inches in a foot. Well, for this chemical reaction, it takes 2 moles of H2O to make 3 moles of O2. Okay, go back through, cancel out my units, moles H2O, and I'm in moles O2, so I can just go ahead and multiply across the top and bottom. So 0.1 times 3 gives me 0.3 on the top, and then I'm going to have 2 on the bottom from doing my multiplication. So 0.3 divided by 2 would be 0.15. So it would be 0.15 moles of H2O would be produced if I started with, 0.15 moles of O2 are produced if I start with 0.1 moles of H2O. Okay, so now that I did that, I'll keep track of this, and then I will go back, and now I'm going to ignore H2O and instead focus on the KO2. And I'll say, okay, well, I figured out that the most product that I could produce with H2O would be, if I started with 0.1 moles of H2O, the most I could make is going to be 0.15 moles of O2. So let's figure out how much O2 I could actually make with this 0.15 moles of KO2 that I start with. So I'm going to do the same thing. I'm going to start with 0.15 mole of KO2, and I'm trying to get to moles of O2 again. Do the same process. Now the multimole ratio of KO2 and O2 is different because there's different molar coefficients. So now instead of this 2 to 3 relationship, I have a 4 mole of KO2 to a 3 mole of O2 relationship. So in other words, 4 moles of KO2, that should be capital, KO2, are equal to 3 moles of O2, or you can think of will produce if you want to. Okay, so that was 4 on the bottom, so 4 moles of KO2, and then 3 mole O2. That mole got a little crazy there. Multiply across the top and bottom because we notice our moles KO2 go away and we're left with mole O2. So 0.15 times 3 divided by 4 gives me 0.1125. So if I look here, well, let's see here. If I had an unlimited amount of KO2 and my only factor that would limit the amount of O2 that being produced was my amount of water, my 0.1 moles of water, I could actually get 0.15 moles of O2. And if I have on the other hand, if I had an unlimited amount of KO2 and water didn't matter, if I had an unlimited amount of water and I only had 0.15 moles of KO2, the most oxygen I could make would be 0.1125. So it turns out that I'm not going to be able to make this 0.15 moles of O2 because I'm going to run out of this KO2 before I get anywhere close to that. So what I'll be able to do is I'll be able to make 0.1125 moles of O2. At that point, all of my KO2 will be gone, and I'll have a little bit of leftover H2O. So in this case, the max amount of oxygen that could be produced would be 0.1125, and my limiting reactant in this case would be my KO2. So this one right here is my limiting reactant. So it's a lot of steps, but it's not too bad. Let's try another one. This one's a little harder. And the only difference in this one is we have to convert from grams to moles first. So it's really not that bad, but we'll try this one. If you're feeling confident, you can go ahead and pause and try this one on your own. If not, I'm going to solve it right now. So if a reaction vessel contains 10 grams of sodium chloride, so I'm going to write that in. It's always a good habit to get into. Do this in a better color here. So 10 grams of NaCl, or sodium chloride, and 12 grams of sulfuric acid, so that's this H2SO4, so 12 grams of that. What is the limiting reactant? So, okay, let's see here. Again, I'm going to need to ignore one of these for now and see how much product I could produce with either 10 grams of NaCl, ignoring H2SO4, or vice versa. I could choose NaHSO4 as my product to look at, or I could choose HCl. It really wouldn't matter. In this case, I'll just do HCl because it's a simpler molar mass. Okay, so let's go ahead and do it. And it gives you some hints. We'll just use the same way we've been going about things. So I can't go from grams of one substance to grams of another substance. I have to go through moles first. But the nice thing is there's actually no large molar coefficient, so everything in front of here is just 1. If it's nothing, it's just 1. So this should be fairly simple. Okay, so I'm going to start with looking at NaCl. So I'll start by saying, okay, well, if I just have 10 grams of NaCl, I ignore H2SO4, how many grams or moles of HCl could I actually produce? So let's see here. 10 grams NaCl, and my end goal here, we can just go to moles of HCl. That should give us plenty of information. Okay, so 10 grams of NaCl. I have to look up the molar mass. I've already done this, and it turns out that NaCl has a molar mass of about 58. I did a little bit of rounding there. For my class, you won't have to worry too much if things are off, plus or minus 1. So don't worry about that. So let's see here. So that means grams on the top. So 58 grams NaCl is in 1 mole of NaCl. And then if we compare our multiple ratio, well, everything's 1. So and up here is NaCl. So 1 mole NaCl is equal to 1 mole of HCl. And go back through, and we can cancel out mole NaCl, grams NaCl, grams. Now I can multiply across the top and bottom, and then divide the top by the bottom. Then I end up with 10 over 58. So 10 divided by 58 gives me 0.17 moles of HCl. Okay, so if NaCl was my limiting reactant, that would mean this is the max I could produce. So let's see if, let's see how many moles of HCl I can produce with my 12 grams of H2SO4 now. So I scroll down a little bit and I say, okay, 12 grams H2SO4, and I want to get 2 moles of HCl. And I've already calculated the molar mass of H2SO4 as well. It turns out that 1 mole of H2SO4 is equal to 98 grams. So 98 grams of H2SO4 is equal to 1 mole. And then that's H2SO4. And then 1 mole H2SO4 is equal to 1 mole of HCl. This one might seem kind of redundant here, this step, but later the multiple ratios probably won't be 1. So it's good to get in the habit. So top is 12. That's nice. And then the bottom is going to be 98. So 12 divided by 98, it's going to give me 0.12. So I get 0.12 moles of HCl looking at the 12 grams of H2SO4 as my starting point. So if we look through here, is it possible for me to produce more than 0.12 moles of HCl? Well, no, of course it's not, because in order to have this reaction actually happen, I have to have my 2 reactants reacting, right? So if one of them runs out, in the case of H2SO4, if that all of a sudden it uses up all of the H2SO4 and it produces the 0.12 moles of HCl, I'm not going to be able to get to 0.17. I'll be completely out of H2SO4. So in this case, H2SO4 is my limiting reactant. All right, guys, I hope this cleared things up, and I will see you in class.